through and divide that, that's just the square root of 9 all over the square root of 64. Both of those are perfect squares. So that just gives me 3 over 8. And that's because 3 times 3 is 9 and 8 times 8 is 64. Be careful with that one because that's not the square root anymore. That's the fourth root of 16 of x over y to the fourth power. So when I go through and break this up, that fourth root of x stays in the numerator. And then this is the fourth root of 16y to the fourth. But we have to be careful, that's 4. So we start with 2 to the fourth power, and that is 16. So when you take the fourth root of 16, that is just equal to whatever that base is. So the numerator stays the same. That's the fourth root of x. In the denominator, the fourth root of 16 comes out, and that's equal to 2. And then the next portion of that will break up again, and that's the fourth root of y to the fourth. Those powers match up exactly. I go back and I check the directions, which is very important. The directions say the variables are all positive real numbers, which is wonderful because that just means my answer is 2y. 3D says the square root of x to the 12 all over 25y to the 8th. So the first thing you do is go ahead and separate that into the numerator and denominator. So that's the square root of x to the 12 over the square root of 25y to the 8th. So the index here again is 2. And both of these are very, very nice because I can say that 2 divides evenly into 12. It goes in 6 times, and that's because 6 times 2 is 12 with a remainder of 0, so there's no remainder. So that just comes out of the radical as x to the 6th. Anything that divides evenly comes out of the radical as an exponent, and any remainder would remain inside, but there's not a remainder that stays inside with this one. Now, the square root of 25 is just 5. And I do the same thing here. 2 divides evenly into 8 4 times, so that would be y to the 4th. That when you rationalize a denominator, it means that no radicals. In the denominator. That's what that means. So if it's just 1 over the square root of 3. The way we do this is we multiply this times 1. But we multiply it times 1 in a very special form. That way that 1 takes form is I want it to be the square root of 3 over the square root of 3. This will always work when it is a square root. Whatever you have underneath the square root, just go ahead and multiply it times itself, numerator and denominator. And the reason you can do that is because multiplying times 1 doesn't change anything. Now, when I multiply that across, that's just going to be the square root of 3 all over the square root of 9. Or you can just go directly to the fact that when you multiply a square root times itself, it'll always just equal whatever the argument is underneath that square root. And this is what is meant by rationalizing the denominator. Now, if you have the square root of, and this is 4a on the worksheet, if you have the square root of 7 divided by the square root of 5, you multiply that again, only by the bottom, because it's okay to have a number in the numerator that's a radical, but it's not okay to have a number in the numerator that's, in the denominator that's a radical. So I multiply that top and bottom by the square root of 5 over the square root of 5. Now when I'm multiplying these across, the 7 and the 5 are both underneath the radical, so I multiply them together. And that gives me the square root of 35. In the denominator, I have the 5 and the 5 are both underneath the radical. Now, you can go straight to this, but if you multiply them together, 5 times 5 is the square root of 25. And then you simplify, so that would be the square root of 35 over 5. Now, the next one, you have a choice. So for B, it is 5 over 12, but it's written as one radical. So first, I have to separate them, and that would be the square root of 5 over the square root of 12. Now, it does help to go through and simplify first, because I know that I can rewrite 12 as 4 times 3, and that means I can take the square root of 4, and the square root of 4 is 2. So I can rewrite that as a square root of 5 all over 2 square root of 3. And the reason it helps simplify first is it'll make the numbers a little bit smaller. I'll do it again a second way. So now I just multiply again only by the radical in the denominator. So that's the square root of 3 over the square root of 3. And when I do that, the square root of 5, which is under the radical, times the 3 that's inside the radical, gives me the square root of 15. Now with this, next one, the 2 is outside, so the 2 doesn't get combined with anything. And then it's just the 3 times 3. So this becomes 2 square root of 9. I can't do anything with the 15. The square root of 9 is 3. And then I multiply those two numbers together. So 2 times 3 gives me 6. Now, a common mistake here is to try to simplify. You can't, because the 6 is outside the radical, the 15 is inside the radical, so you cannot simplify that fraction. So I just went ahead and multiplied the, top and bottom by square root of 12. And now I need to go ahead and simplify that. And the square root of 4 is 2. Which gives me 2 square root of 15 all over 12. Now, because the 2 and the 12 are outside the radical, you can simplify that. 2 goes into 2 one time and into 12 6 times. So that is equal to the square root of 15 over 6. So you'll get the same answer either way. It just depends upon how you want to go through and do that question. So if I have 2x plus 4 divided by 2, how would you simplify that? You would have to factor, correct? And make that 2 parentheses x plus 2 all over 2, then the 2's can cancel out and you would be left with x plus 2. A common mistake that I would see would people do this. They would cancel those 2's out. And if you told me that it was equal to x plus 4, that would absolutely be incorrect. But it was a very common mistake I saw. Now, with these in particular, because we are getting ready to go through and do the quadratic formula, there is kind of a shortcut. And I want to show it to you. If it was 2x plus 4 divided by 2. If I can go through and take all three of these numbers, and kind of think about the shortcut as a little smiley face, right? 2 divides into 2 evenly one time, and 2 times, and that would equal x plus 2, the same answer. So before I can do anything with this, your first step should always be to simplify the radical. That equals 4 minus the square root of 4 times 10, all divided by 4. And you cannot use a shortcut yet. Because the only time you can use a shortcut is if all the numbers are outside the radical. So the square root of 4 is 2. So I'll go ahead and rewrite that. And that equals 4 minus 2 square root of 10 all over 4. So now it's okay to use a shortcut. I'm asking myself what three numbers will go into the 4, the 2, and the 4. And that is, we're going to divide each of those numbers by 2. 4 divided by 2 is 2. 4 divided by 2 is 2. And 2 divided by 2 is 1. So that is equal to 2 minus 1 square root of 10 all over 2. You don't have to leave that 1 there, so that would be 2 minus the square root of 10 all over 2 for that final answer. Okay, so this is the first one where you might not see right away what to divide into and how to break up 196, but we do want to do that first. So the first thing is, let's look at 196. And we're going to check to see what the perfect squares. Is 196 divisible by 4? And it is. 196 is divisible by 4 and 49. Oh, this one's quite easy. What that means is, you probably already did this in your calculators, that's the square root of 4 times the square root of 49 all over 2. The square root of 4 is 2. The square root of 49 is 7. And that just becomes 16 minus 14 divided by 2, or 2 over 2, which is equal to 1. Well, that was kind of easy. So we probably should do at least one more. So let's go ahead and look at we'll look at D, which is 4 minus the square root of 8, all divided by 2. So again, the first thing we want to do is simplify underneath that radical. So I rewrite that as 4 minus the square root of 4 times 2, all divided by 2. The square root of 4 is 2. So I rewrite that as 4 minus 2 square root of 2 all over 2. Now remember, and I'm going to keep saying this because it's, do not combine the 4 and the 2. Those are two separate values here. So that, at this point, what we can do is then take one number that divides into all three numbers that are outside the radical, and I'm going to divide each of those three numbers that again are outside the radical by 2. And when I go through and divide them all by 2, 4 divided by 2 is 2. 2 divided by 2 is 1. And 2 divided by 2 down here is also 1. So all of that would equal 2 minus the square root of 2. It's over 1, but because it's over 1, you don't have to write that 1 of the denominator. That would just be 2 minus the square root of